Okay, hi everyone. I'm Ellie, Marketing Executive at Signify Technology. We are joined by Maciej. Maciej is a Scala developer with a passion for Scala on Android, Rust and AI. Today he will be giving his talk on one of those passions, Scala on Android. So over to you, Maciej.
Thank you, El. I hope you hear me well, all of you. Yeah, I write Scala on Android, and we have a lot to talk about. Let me share my screen. Share screen. Okay, and here we go. So at the I/O 2019 conference, Google announced that the number of Android devices in the world surpassed 2.5 billion. Despite the highlighted comment below the tweet here, this is a remarkable achievement. In May 2017, it was 2 billion devices, and in September 2015, it was 1.4 billion users, which is not the same as the number of devices, but anyway, it shows that the growth is steady, even though there's only a finite number of Homo sapiens in the world. In 2019, there were 2.71 billion smartphone users, so even taking into account that one person can have more than one device, it clearly shows that Android is by far the biggest platform on mobile phones, and also in absolute numbers, the most popular operating system on Earth. It scores consistently at 70 to 74% of the mobile market. And its biggest competitor, that's Apple, is at 25 to 28%, and other platforms basically don't exist. On top of that, the landscape of mobile platforms is uneven. iOS phones are on average more expensive, and they are more popular among wealthy countries and among wealthy people like us. That's why we may think that Android and iOS are more even than they really are. Like here, for example, everywhere around the globe, in Africa, in Asia, also Latin America, Middle East, even Eastern Europe, those markets are full of Android devices, and those markets are growing fast. So yeah, this is Asia. But this talk is not about bashing Apple and cheering for Google. Well, quite the opposite, really. Here, I just want you to see that the size of the Android platform is enormous. It's bigger than we may imagine when we just have our phones in our hands, and it can't be ignored. Some more data. In 2019, 70 to 80 of internet traffic came from mobile devices. A vast majority of it comes from apps, not from mobile-friendly websites. And even though we're talking here mostly about big apps like Facebook, Twitter, Instagram, etc., those big apps created a culture of looking for an app that will let us do something, and instead of going to an all-purpose web browser. And by the way, a web browser on a mobile device, it's an app as well. There are currently 3 million apps in the Google Play Store. Those apps are written mostly in Java and Kotlin, but also in a few other languages. So maybe the sheer number of repositories on GitHub doesn't mean much without context, but we can look into it, we can look into proportions. Java rules on the Android. It's safely above Kotlin, but we have to remember that Kotlin is a pretty new player here. Only at the I/O 2019, Google announced that it chose Kotlin as the successor of Java on the Android platform. JavaScript is the third, and Dart is fourth because of Flutter. Flutter is also the most starred Android project on GitHub, and that's why it's visible in the background on the screenshot. We will talk about both of them too. But before that, well, if Java and Kotlin are so prominent, then why don't we see Scala anywhere here? After all, Scala is the second or third execvo with Kotlin nowadays, language from the JVM. If we dig deeper, we will find that there are 45 public repositories on GitHub for Android written in Scala out of 77,000. Even there are many more C++ repositories than Scala. And most of those 45 repositories are abandoned, or they are just small weekend projects. From those that stand out a little, we have the Android client of my employer, Wire, and there are our friends at 47deg who experimented with Scala on Android a few years ago. They made an application that tracked talks at the Scala Days conferences, and I really appreciate it, guys. No irony here. It wasn't always like this. From 2014 to around 2016, we saw the rise of a few Android projects written in Scala, both libraries and end-user applications. The interest in Android was always small among Scala developers, but for a moment it looked like it can be enough, like we can be there. After all, Android apps depend on good event handling and reactivity. They are usually small in comparison to backend programs. They are built by small teams that need to act quickly and write safe and sound, but also concise code. Android looked like a perfect place for Scala, and that's exactly why Wire chose Scala for its Android application. And for some time, it made sense. We had three main ways to build Android applications. Two of them through plugins to two main build tools, FBT and Gradle. If you wanted to go more Scala way, then there was an FBT Android plugin. If you wanted to go more standard Android way, possibly because you wanted to mix your Scala code with older Java code, you could have used the Gradle Scala Android plugin. And there was also Scaloid, a library that tried to wrap that hot mess of mutability that is Android SDK, wrap it into something more suited for functional programming. All three were created in around 2014, were developed and maintained through 2016, and then slowly died in 2017. There are at least a few reasons why it didn't work out. There were some decisions made at Google. There was a fact that the Scala community is small and mostly oriented at the backend, and so decisions were made to focus on that. Here, though, I want to talk about the technical problem that proved to be impossible to overcome, and it was one of the main reasons. In March 2014, Java 8 was released, and among other features, it introduced support for Lambda expressions in Java and the JVM bytecode. Scala, of course, had Lambdas much before that, but during compilation to the bytecode, they had to be replaced with what on the Java language level amounted to creating a new inner class. Then there had to be code that was the equivalent of the Lambda expression. Then we had to create the instance of that class, and finally we had to call the method on that instance. Think for a moment, how many Lambda expressions do you use every day in your Scala code? And imagine that for every Lambda expression in Scala, there has to be a separate class. You can easily see that it both made the resulting bytecode larger than necessary, and it used more memory, and also was slower because it had to handle all those instances. So it was only natural that Scala embraced the new functionality, and when in November 26, Scala 2.12 was released, it required the new JVM. The resulting bytecode was now smaller and quicker. Developers of Scala libraries and frameworks quickly followed this suit. New versions of their projects took advantage of new lambdas on JVM, but there was a problem. The problem is that what the Android platform uses is not really JVM. The old Android's virtual machine is called Dalvik, and the later ART, which replaced Dalvik, they both take Java bytecode classes and translate them even further into their own bytecode. That bytecode is more optimized for low memory requirements, but also it means that Dalvik and ART are not required to understand every JVM instruction. And for example, when Java 8 was introduced with the support of Lambda expressions, Dalvik and ART stayed the same. And when Scala 2.12 was released, it turned out that it was impossible to use it on Android. In the beginning, it wasn't such a big deal. After all, Scala 2.11 was still supported. From the comments on the SBT Android plugin GitHub repository and from GitHub, we can see that people believe that the Lambda problem is just a bug like many others. On the Gradle plugin side, we at Wire and many other people too forked the plugin and tried some experiments, but without much success. And then the I/O conference happened in May 2017, and Google chose that it will support Kotlin as the main programming language on the Android platform. Together, the Google decision about Kotlin and the Scala decision about Java 8, so close in time to each other, it sent a very strong message. If you prefer Scala, don't think about programming on Android. If you prefer Android, look into other programming languages, so namely Kotlin. And then, with time, libraries of the Scala ecosystem started dropping support for Scala 2.11, and in 2019, even Wire changed its course. Like we started to look for Kotlin developers and started to rewrite the Wire Android app in Kotlin, which slowly continues to this day. Yeah. Okay, let's maybe switch to a bit more positive slide. Okay, again. So maybe it's Eastern Europe in me speaking. In Eastern Europe, we often expect the worst to happen. And so then when it happens, we are prepared for it. We get a bit cocky and say something silly like, this is problem, this is not problem. When it was -30 and polar bears walked the streets of my town, that was problem. So we make a show and make sure you know why everything is wrong, but in the end, we go back to work and get things done. So I already complained to you why everything is wrong. Now let's start with the second part. We're now in 2021 and we're back at square one. Scala on Android is almost non-existent. We gave up the biggest IT market on the planet. Do I want to convince you that it makes sense to try again? Yes, that's exactly what I want. Is it a realistic idea? Yes, I wouldn't be here if I didn't believe in that. But we need to face the facts. No company will risk using Scala on Android in the current situation, both for technical reasons and because there are not enough Scala developers willing to work on Android with old Scala 2.11 and old tools. But how can we have better tools and more Scala developers on Android if companies are not interested in this? It's like a chicken and egg problem that we should have avoided years ago. Now we need another way through open source to overcome that Lambda expressions issue, to update tools and make a small but alive community of people willing to write Scala on Android. Fortunately, we are not alone. But first, let's take one thing out of the way. In August 2017, Android 8 came out with support for Lambda expressions. From this moment, I believe it's this dark line here. From this moment, in theory, it's again possible to update one of the plugins and compile an Android app with Scala to 12. It wasn't very practical back then because in 2017, almost no one had Android 8, but now in 2021, only around 10% of mobile phones run on Android below 8.0. We could decide that, okay, we will ignore all the Androids and the new plugin will allow for modern Scala on newer devices. Problem solved? No. Unfortunately, that's not true. Even on Android 8 and up, Art is not completely compatible with Java 8. The Lambda issue was the first and the most prominent one, but there are more. We just didn't get hit by them because we were stopped by the first one, something like in a role-playing games, like when a local boss kills the hero before the hero is able to reach the final level. This comment here on the slide, this comes from the GitHub repo of one of the plugins. The author tried to do exactly what I described above. Unfortunately, this doesn't work. The easiest way to reproduce, create Gradle Android plugin, Android project with minimum SDK 26, that's Android 8, Java version 1.8, enable multidex, add Scala 212 standard library as dependency, and try to call something like option apply 1. It will fail on runtime with error incompatible class change error, even on Android 9. Yeah, in part that's because Google breaks things all the time. New libraries replace the old ones every year or two, just to be replaced by even newer ones. Important functionalities are getting deprecated and new alternatives are introduced which don't improve anything much. They just require us to do the same things in a different way. Every time a new Android version comes out, the apps that worked fine on the older one start to crash on the new one in random places. And Stack Overflow fills up with questions about it and answers like, oh, since this version you need to do X before you do Y, or you will get a WTF exception in the Z place. People who worked on the plugins and the Scala library just couldn't possibly catch up, like, no way. Any smaller company would quickly lose customers if it acted as Google does. But Google is Google, so where Android developers are supposed to go? We just move along and try to keep sane. Fortunately, there are a few who resist. Remember when I showed the number of Android projects on GitHub? There was a small but not insignificant number of those projects written in JavaScript and Dart. They are the result of the fact that Android is not the only end-user platform in existence, even if it is the biggest one. There is iOS, but there is also the web, and believe it or not, there is desktop. To cover all bases, IT companies need to provide apps for all of them, or at least the three major ones. But Android means Java or Kotlin, iOS means Swift, and web means JavaScript in its many forms. That means 3 teams of developers working basically on the same app, but in very different technologies. In response to this situation, a few frameworks were created that try to make it possible to write the code once and then somehow run it on all platforms and get similar decent user experience. We can safely forget about Flutter here. Flutter is from Google and it requires people to code in Dart, but there are others. Back in May 2013, Facebook released React, its front-end JavaScript library, and in March 2015, that was followed by React Native. Before that, Facebook experimented with HTML5 to create a mobile app that would work like a web page in a container. That attempt failed, but the general idea proved to be interesting. Only the implementation had to be on a different level. So JavaScript instead of HTML5. React Native allows developers to write their applications in JavaScript and then compile them to native apps on a given platform, Android, but also iOS, Mac, and Windows. If you ever used the Facebook application on your phone, you used React Native. Or if it was Instagram or Discord or Pinterest or a bunch of others. Okay, well, if something can be written in JavaScript, it can also be written in Scala.js, right? And as a bridge between Scala.js and React Native, we can use Slinky. So here's the whole stack. Even though React Native was created by Facebook, it's an open source project. You can think of it as an ally in the fight against whatever Google throws at us with every new SDK. It's not a completely bulletproof shield, but since React Native is open source and so are Slinky and Scala.js, our relationship with them is on a completely different level than it is with Google. A disadvantage is that, well, I don't think that people from React Native really know anything about Scala.js. Working with the stack, we will surely run into some bugs and things will start to be difficult the moment we will try anything unusual. But just start playing with it, build an app. If anything goes wrong, you can go to one of those projects, file an issue, or even better, try to fix it yourself. And the project maintainers will help you if they can. This way, the whole community will profit. And the more people will work like that, the better every one of us will be. Yet another advantage is that by using the stack, we write applications not only for Android, but for other platforms as well. There are differences among those platforms, and you will need to put some additional effort to have your project work on all of them. But still, it is much better than writing an app directly in Android SDK, where on top of all other problems, we also have that this is an app written only for Android. And if we want the same app to be for iOS, for example, we have to write it again from scratch. So that's React Native, but that's not all. There's at least one more approach I'd like to tell you about, one that gives us a similar set of advantages, but in a different way. Gradle VM. It's a new Java virtual machine and development kit. It supports more programming languages than we can possibly ever need, and also execution modes like an ahead-of-time compilation of Java for fast startup, low memory footprint. The first production-ready version was released in May 2019, and the current one is from this January. Scala is just one of many possibilities here, and it's in fact one of the easiest one to include because it's already on JVM. But it's the other end of Gradle VM that is interesting to us, namely what Gradle VM can compile our code to. And from November 2019, Gradle VM comes with a tool called native image, which takes the Java bytecode and turns it into an executable on a given target platform. The platform can be Mac, Linux, Windows, iOS, Android, or even embedded devices. But the ability to compile a program is not enough. An application needs to be able to talk to the underlying operating system. It needs to display widgets on the device's screen, and the user needs to be able to interact with them. The app also needs to be able to access the storage, the database if there is one, various functionalities. In the React Native stack, this is handled by React Native, but Gradle VM is just a compiler. And we need one more element in this puzzle. Here comes Gluon. Gluon is a company which provides functionality for talking to the operating system. and which is also the maintainer of JavaFX, a Java UI library. JavaFX is nothing new. It was initially released in 2008 as a part of the standard Java JDK, and from there it had a bumpy road for some years. In 2018, it became an independent open source project, and in my personal opinion, since then it's growing faster than ever. It even became a base for a few other graphics and widgets libraries. Among other things, it provides the UI components for mobile applications, like ones written with Gluon and Guardium VM. Also, if you want, on top of JavaFX, you can use ScalaFX, but you can also simply use Scala to Java converters. Just as in the previous case, we can write almost the same code for many platforms, and we have a layer shielding us from Android, and that layer is open source. If anything goes wrong, we can go to one of the projects and try to fix the problem with help from the maintainers. And the disadvantage, again, is that there will be some things going wrong on the borders between all these products. But also, every time someone fixes one of the problems or finds a solution, that is useful to everyone else. So, like, it's scalable. It's the more hands we have on board, the better it will get. A few words about a comparison between those two stacks. In my personal opinion, the difference is mainly that in Scala.js we have all the good stuff that web development gives us. It could be possibly a better choice if you want a great unconventional user interface. In JavaFX and ScalaFX, we might find that it's a bit more difficult to experiment with UI. But on the other hand, the app compiled with Gradle VM might be possibly as well smaller and faster. So it could be better if you wanted to write a more resource-heavy application like a mobile video game, or maybe you want the app to work well on weaker phones. Okay, but I don't want you to think that there's some sort of competition here. There's nothing to compete about. At this moment, there's almost no Scala presence on Android. No company except Wire writes Scala on Android on a big scale. If right now you will put in your CV that you wrote an Android app in Scala, well, that won't give you any points, except maybe as something interesting you can talk about in an interview for a different job. If we want to have Scala on Android, we need to invest our time and energy. We need to reach out to each other, help each other across time zones, programming languages, and human languages and cultural borders as well. It won't be easy, but if we do, I can assure you that it will be rewarding. It will be fun. And one day we will have our own space on the Android platform, and albeit a small one, we will be able to say that, yes, we made it happen. And one correction still needed. I started talking about Scala on Android, but as I mentioned many times, both approaches I propose are cross-platform. They enable us not only to write Scala on Android, but they enable us to write Scala on basically any end-user platform. And with this, I think it's time to wrap up. My project for this year is to create a bunch of tutorials and examples for the Gradle VM tech stack. And finally, I hope it will lead to me publishing a small mobile video game. Already under this link here, you can learn how to build an example Android application. Much more information, I hope, will be coming in the following months. Besides, you can always reach to me, and I'll try to help you the best I can. Thank you very much.